Hello, good day, folks. Good day, friends, and good day, all mathematics lovers. You're all welcome to Math in a Flash channel. Today, we'll be looking at the subject of logarithm. So, we'll be starting the subject of logarithm, and we'll be looking into what it is and how best to solve it. So, in the previous class, we looked at the laws of indices. So this is just more like a continuation of from where we stopped at the laws of indices. We just continue from there. So in indices, we noted that when we have multiplication in indices, you simply add, and when there's a division, you subtract. So just as a way of revision, we noted that when we have powers in multiples of tens, that's 1000 being 10 raised to the power 3 in logarithm, except where defined it is assumed to be in base 10. So log 1000 is 3. That's more like the reverse of the power. So where the power 100 is 10 raised to the power 2, log 100 is 2. And where the power is 10 raised to the power 1, the log of base 10 is 1. 1 is 10 raised to the power 0, meaning any number or letter raised to the power 0 is assumed to be 1, and in like manner, log 1 is 0. So we'll be using the 4-figure table to find the logarithm of numbers today. And hopefully in our part 2 of this subject, we'll be looking at how to use it to compute difficult questions. We'll be attempting difficult questions. But for tonight, we'll just be looking at how to use the 4-figure table to find the logarithm of numbers. The 4-figure table is it's an accompanying resource that you could fetch online. You could go to Google, just download the digital copy of the 4-figure table, and you could have a free access. So with the 4-figure table, you can determine the logarithm and antilog and some other stuffs that you can do with the 4-figure table. It's quite numerous, but we'll just be looking at logarithm from just an intro level. So we'll be looking at how to use the 4-figure table to find the logarithm of some numbers, just like I said. And this channel is poised to helping you navigate and solving questions easily. They're like we just go straight to the point without beating around the bush. And the way and manner with which we do that is to simplify the problem. We will simplify the problem. So without much ado, so we will just delve into today's subject. So how do we use the 4-figure table to find the logarithm of numbers? So to start with, I want to simplify it. So when we have questions that borders on logarithm, it's simple to approach. So in this case now we have 3.7. Just like it said, 4-figure table. So it's assumed that we are working with a 4-digit number. So by 4-digit number, I mean a number like 3200. This is a 4-digit 1, 2, 3, 4. Then 3.200, like this also 4. We can classify this as a 4-digit 1, 2, 3, 4. And then 0.002, 1, 2, 3, 4. Same. So you can see that all these are 4-digit numbers. So I want to simplify this because I don't want us to waste much time on this. So we have 3.7 as our first task. 3.7. So how do we determine the logarithm of 3.7? 3.7 if written is 3.700. 3.700. That's fine. So to simplify it, now after this is the decimal point, this is the location of the decimal point. Before the decimal point, we have just one digit before the decimal point. and after the decimal point we have 3 digits: 1, 2, 3. So to start with, so you count the number of numbers digits before the decimal point. We have 1 digit before the decimal point. So the very first thing to do is, there is always the standard of 10 raised power 1, 10 raised power 1, 10 raised power 1. So count the number of digits before the decimal point. We have 1. So just subtract 1 from it, and that will give you 0, like this. Then the next thing to do is to call this digit like this: 37 under 0 difference 0. 37 under 0 difference 0. Let me bring in the 4-figure table so we see what it looks like and how to use it. The 4-figure, I want to bring in the 4-figure table quickly. Okay, so this is the 4-figure table. This is what it looks like. This is a 68 page, but I will just go to the page where that we need a page that we need to work with. Okay, so the question again was 37 under 0 difference 0. So if we look at this 4-figure table, I will use the red color. If you look at this 4-figure table, this is 37 here. So sorry, it's tiny. I want to believe if you can get an online copy, it will be better for us. So this is 37 here, 37, and this is the number under 0. That's under 0, under this 0, we have 5682. 37 under 0, 37 under 0, under 0 equals 5682. Then you go to the other length and the other section, difference 0. You can see that there's no difference 0. We have, it starts from 1, 2, 3, 4, 5, 6, 7, 8, 9. So just follow along that same row. There's no difference 0. So you had the difference to it. So you had the difference to this. So that will give us 0.5682. So 3.7 expressed in logarithm. We have 1 digit before the decimal point. Remove 1 from it, that will give you 0. So that will be 0.5682. So that will be the answer, 0.5682. So the next question was 37. So in like manner, let's look at 37. So the next question, log of 37, log of 37. So 37 can be written as 37.00. 37.00. So what this means is 37 under 0, under this 0, and difference 0. So this one is difference, and this is under. This is where we call the under. 37 under 0 difference 0. So you come again, you look in here, 37. This is 37 under 0 is 5682. 5682. So but the number is 0.5682. So 0.5682, then plus the difference starts from 1. So there's nothing, no record of difference. So that will be 0.5682. But because this is 37, it's a 2 digits before the decimal point, you remove 1. So that will be 1.5682. Or we can say 1 plus 1 plus 0.5682, and that will give us 1.5682, and that will be the answer. That will be the answer for 1.5682. So in like manner, so if we are to find the log of 3 log of, let's say we are looking for log of 3700. So you write it like 3700. This is like a 4-digit already. And just point zero, it's a 4-digit already. So you call it the same way: 37 under 0 difference 0 under under 0 under here and here difference. So 37 under 0 difference 0. But how many digits before the decimal point? We have 4. 1, 2, 3, 4. 4 digits before the decimal point. You remove 1. That will be 3. Then plus 37 under 0 again is 0.5682. We have 0.5682. In order not to be confused, 3 is the same thing as 3.0000, and 0.5682 will be 0.5682. When you are adding up, the decimal point must align. So this is me adding up. 3 plus 0 is 3.5682. So this is the answer. This is the answer of log 3700. That will be 3.5682. Hope you are finding value with this. If you have found value so far, please like, share, and subscribe to my channel so that more people would have access to this information and this explanation. My quest with this channel is to make maths easy and to make it as simple as possible. So everyone can, for the benefit of all. So the next question said we are to write the logarithm of the following: 1005 times 1005, 1005 times 1005. So let's bring in the 4-figure table. So quickly bring in the 4-figure table. So the question was, the question again is 1005 times 1005. So let's solve it together. 1005 times 1005. So we have to express this. We have to find the logarithm of these numbers, these two numbers. So how do we treat this? You just draw your line, number log, number, and logarithm. On the right hand side we have the logarithm. On the left hand side we have the digits, that's the numbers. So 1005, and we have another 1005 here. Just like I explained earlier, so 1005 can be written as 1005.0. 1005.0. That's 4 digits before the decimal point: 1, 2, 3, 4. So what you need to do is just to write 3, then point. So you call it like this: 10 under 0 difference 5. So you go to where 10 is. 10 under 0 is 0, 0, 0, 0. Then difference 5 is 21. So that will be, this 0, 0, 0 is 0.0000. So that will be 0, 0. Then difference 5, which is 21. Look at it here. Difference 5 is 21, 21, 21. You add the 21 to it. That will be 21. Again, I repeat it again. So we have 1005. So that will be 4 digits. Again, I'm writing it here for the benefit of those who do not understand. 1005 is same thing as 1005.0. How many digits before the decimal point? We have 4 digits. So we just remove 1. That will give us 3.0021. 3.0021. I want to erase this 3.0021. So because we are multiplying in indices, whenever you see a multiplication sign in between, what you need to do is to simply add. You add up the two numbers. 1 plus 1 is 2, 2 plus 2 is 4, 0 plus 0 is 0, 0 plus 0 is 0, and 3 plus 3 is 6. I am adding because of this multiplication. That is why I'm adding here, because of the multiplication. In indices, multiplication is addition. So we have 6.0042, but that is not the answer. So from our four-figure table, we now shift to the antilogarithm of the logarithm, antilogarithm of the logarithm. We have a log in the four-figure table. We have a logarithm section and we have the antilogarithm section. So we look for the antilogarithm section. So this is the antilogarithm section. But before then, let's quickly check it. 0.00 under 4. So this is how to check it. You said 0.00. Antilogarithm starts from point from the decimal point. So we say 0.00 under 4 difference 2. This is under 4, and this is the difference. So we are looking for 0.00 under 4 difference 2. So I'll shift to the antilogarithm section. This is the antilogarithm. See it here? This is the antilogarithm section. So you start from 0.00, 0.00, 0.00 here, 0.00 under 4, which is 1009. Then difference 2, which is 0. So that will be what? 0.1009. Don't forget that in indices, sorry, in mathematics, after the decimal point, you call the digit one by one. 1009. I want to rewrite it for clarity. So we have 0.1009. 0.1009. That's 0.00 under 4 difference 2. So that will give me 0.1009 when I find the antilog of this. Antilog of this 0.1009. Now there's a 6 in front of the decimal point. There's a 6 in front of the decimal point. What you need to do is to add 1 to the power of 10. And you add 6 to the power of 10. That's the 6 in front of that number, of that decimal point. That will be 10 raised to the power 1 plus 6 times 0.1009, meaning this is 7. So you have to move the decimal point 7 times. So that will give us 1, 2, 3, 4, 5, 6, 7. So I'll put a 0 here and a 0 here, and the decimal point, the last decimal point here. So the answer will now be 0.100900. Don't forget the decimal point is now here. So when you are using indices, logarithm, the answers are approximate. It may not be the exact, because you are using four-figure table. It may not be the exact value, but an approximate value. So that should be the answer. So that's the answer. So let's go to the next topic before we now call it a day. I don't want us to rush into. We'll still solve quite a number of these questions. But I don't want us to rush into it. Okay, so let's go into it. The next question is 912.4 divided by 53.55. 912.4 divided by 53.55. So let's bring our four-figure table in. The question again is 912.4 divided by 53.55. This is the question. So let's use our calculator to see what we are expected to get. So we are going to get an approximate answer, but at least very close to it. 912.4 divided by 53.55, and that will give us 17.038. Okay, that's good. 17.3038. So let's start with this. So to start with, we draw a number log. Just follow me, you will get it. You draw a number log table, number and log. Inside the numbers, we have 912.4 and we have 53.55. So here we said 3 digits before the decimal point, 912.4. So that would be 3 point, and this is 2 digits before the decimal point, 1 2 before the decimal point. Just should remove 1, that would be 1 point. Good. Now for the first number, we have to look for 91 under 2 difference 4. 91 under 2 difference 4. So let's move a bit to the front. Okay. So I'm looking for 91 under 2 difference 4. 91 under 2. 91 under 2. So 91 under 2, I think that's 9,600 if I'm not mistaken. 9600, then difference 4 is 2. So that will be 9602. I'm to add this 2 to it. So that's 9600 plus 2. That's 9602. 9602. So that should give us 9602. The next number is 53 under 5 difference 5. 53 under 5 difference 5. 53 under 5. 53 under 5 is so look at the fifth column. 53 under 5 is 7284, and difference 5. 7284 difference 5 is 4. 7284 plus 4 is 4 under 5. 7284 plus 4, that will be 7288. 7288. 7288. Good. Now, because of this division, I have to subtract. So I'm subtracting. So 2 minus 8, I'm to borrow 1. So that will be 12 minus 8 will be 4. 9 minus 8, 1. This will be 5 minus 2, that's 3. Then 9 minus 7, 2. And 3 minus 1, that's 2. 2. Or better still, we can bring in a calculator to just quickly to make it easier. So quickly bring the calculator in. So 3.9602, 3 point. So that 3.9602 minus 1.7288. 1.7288. So 2.2314. Okay. So the next is to find the antilog of this number. Find the antilog. Okay, so we have to find the antilog of this number. Antilog of this number. Antilog. So to find the antilog of this number, we are going to start from the decimal point, 0.2314. We are looking for the antilog of 0.2314. So you go to the section where you have the antilog. Okay. So it goes to 0.23. This is 0.23 under 1, which is 1702. 1702. Difference 4 is 2. So 1702 then plus 2, 1704. That will be 1704. That will be antilog is 0.1704. But that is not the answer. So there's a 2 in front of the decimal point. So you add 1 to that 2. That will be 10 raised to the power 1 plus 2 times 0.1704. And that will be 10 raised to the power 3 times this. 10 raised to the power 3 times 0.1704. And that will be, you move the decimal point 3 times, 1, 2, 3. So that the answer will be 170.4. 170.4. So we can bring in the calculator to check if our answer is correct or wrong. Like I said, you may not get the exact answer, but at least you should get an approximate, because we are using a 4-figure table. So the question again was 912.4, 912.4 divided by 53.55. See, oh yes, there must be an error somewhere. 912.4. Okay, let me check the 0.23 under 1 difference 4. 0.23 under 1. Let's see. I see the error. So we have 912.4. This is meant to be 2. So sorry for that. I was wondering where I made a mistake. I was wondering where the error came from. Okay. So this should have been 2 because 3 digits before the decimal point 3. So 3 minus 1. This should have been 2. Apologies for that error. So if this is 2, then this becomes 1. This becomes 1. So I'll quickly go over it again. It said 3 digits before the decimal point, you have to remove 1. So that will be 2.9602. 2 digits before the decimal point, you have to remove 1. You have 1.7288. So when you subtract it, you get 1.2314. Then the antilog of 0.23 under 1 difference 4 is 0.1704. Then this one, you add this one, there's a standard one already, you add another one to it. So I will erase this 2. To add 1 to it. So that will give us 10 raised to the power 2. So if that gives us 10 raised to the power 2, so this would have to be redone. So this will give us 10 raised to the power 2 times 0.1704. Meaning I'm moving the decimal point 2 times 1, 2, and that will give me 17.04. And that's the answer, 17.04. So sorry for the error. So it happens. That's why it's always good to be thorough when solving math questions. You just might make an error, that inexplicable error, I would say. But that notwithstanding, it's always good to be thorough when solving mathematical questions. So at this juncture, so we'll call it a day for today. Hopefully you've gotten value from tonight's class. So I want to believe that you would practice more, and tomorrow we'll look more into more difficult questions. We'll solve the remaining questions, and I have a take-home assignment. And if you found value at this juncture, I want to urge you to please subscribe to my channel, like and share this video, so that very many people who are having difficulty with mathematics will find it easy. Thank you so much.